Welcome. Hello, everyone. Thanks for joining. This is a new edition of On Air from Swiss Eye Weeks and Wildcard Media. And today we have again Dr. Dietmar Schaftarik. And we have the second Power Workshop, AI Reality Check, Health Tech Use and Misuse. Invisible failures when AI breaks without breaking. And Dietmar is from Regulatory Thinking, the home of regulation. And I heard that you had some homework, so I'm very curious how it went and wishing you a great session.
Okay, thank you. So welcome to this second part of our mini-series about AI in medical devices or in health tech products. I try to share my screen. Hopefully it works. So 1 second. So now I need a yes or no because I cannot see you. Yes, okay. So this is the title of our 2 days short talk, Invisible Failures when AI Breaks Without Breaking. And as I was introduced, my name is Dietmar Schaftarik. I'm a serial entrepreneur in medtech. I'm a senior lecturer DHEST at ETH in Zurich. I'm teaching regulatory and certification. I'm the regulatory expert at ETH. And in addition, I'm a diploma lead auditor and lead technical assessor for some certification bodies and notified bodies. Today with me in the lecture is my colleague Nico Mangold. He's a founder and the managing director at Mangold MedTech Consultants. He is also a technical assessor and he is an expert also in digital health and software as medical device. And he is with me a little bit observing the chat. So please feel free to write and type in your questions in the chat. Nico will monitor this and Nico will also help me at the end if we have time to discuss the most important topics or the most important questions. And so today's topics is, again, we will have a real world case. I will introduce you to the problem and we will try to detect some patterns there so that we can learn from this problem, maybe to your medical devices, to your AI approaches. We will highlight a little bit why quality assurance has missed these problems. We will try to detect a fast lane, how to spot this kind of failures and problems. We will shortly discuss possibilities to prevent it. And of course, we will give a kind of a small compliance and improvement loop. And so today's topic, maybe some of you remember last time there we have had the failure with the fertility management app. Today we have a kind of a silent scandal. You have to imagine a hospital rolled out a chest X-ray AI and everything looked great. The investors have been happy. The reports have been great. But at a few news sites, the tool kept flagging urgence, although the scans looked fine. And weeks later, the team discovered the twist. And the problem was the AI wasn't reading the lungs on the X-ray. It was reading little corner logos or symbols or icons that happened to appear more often on scans from a sick population at the training sites. And so if you find this icon with the child playing in the sandbox, then we are leaving the regulatory language and are talking in a layperson's language to get the picture a little bit better. Imagine a robot that gets gold stars for sorting pictures, but it was starting at stickers in the corner, not the real picture. It guessed well, but for the wrong reason. And so the model didn't break. But it never worked the way we thought or the company thought. So this is in a nutshell the scandal, the real world case that we want to present to you. And because this artificial intelligence was implemented in a hospital, also the patients got problems. Yeah. So what happened? The AI took a shortcut. It linked symbols. You can see it in my picture on the left-hand side. This plus symbol. This is an example. It linked symbols on patient's imaging with the output or the result, patient probably sick. And of course, there have been double checks and also the examination by the surgeons. So nothing happened with a real patient, but it is dangerous because patients at other hospitals were under or over prioritized based on picture decorations and not on their health. So for the triage, it was really a problem. And you have to imagine all the dashboards and tests still shined green, looked good, no alarm rang, because they used similar data. So this is really the problem that we had to assess and to try to find some solutions. And as I have said, the system check said all systems working, everything is okay. In the reading room, no alarm, all green lights. So it was really a silent failure. And the question was how this shortcut was born. Why started the AI to detect symbols or logos on a patient's X-ray and tried to analyze this symbol? As a result, the patient is sick. And so you maybe can imagine that I would grade the essays of students or scholars in my teaching courses by the paper color instead of content, because past top students used grayish paper. And so this is the same what happened to this AI. This AI created a shortcut to learn. The AI did the same. It saw logo stickers, borders, scanner frames, and used them as hints for disease. And so you can also say or rephrase, the robot looked at the bow on a present and not what was inside the box. This was the problem. And as I said, no alarm went on. The dashboard blinked green. It was calm and quiet. And the question is, why no alarms rang? And the answer is because they let the robot play in the same room as it was practiced in. And of course, it does it well. And outside the room, the robot failed. And they have trained and tested within the same data sets. And so this is always a big problem and always a takeaway for you. Use different data sets to train and to verify your artificial intelligence. This is absolutely a must, and there are big failures if this is not followed. And there is also the big number trap. A high AUC, an area under the curve, indicates wrongly a safe model. And they had a monitoring gap and they missed some change controls. And so you see, they have not been aware about these shortcut failures. And they did some important mistakes at the very first beginning, where they trained and tested their artificial intelligence. And so we did a kind of a reality check versus the performance claim. And you see here on the picture, what was the problem. On the left-hand side, you see, and I made it a little bit bigger so that you can see this. There was a symbol, there was an icon on the patient's X-ray. And the AI detected the area as maybe a problem for the health of the patient. And you see this red and yellow shining area is definitely not the lung. It's the area of this kind of the icon of the plus symbol. Name the pattern. It is an invisible failure. And I say we can see here a kind of a pattern because we really see that this happens more than one time. And so we also can try to find a definition how to define this kind of failure. And the definition could be the tool appears to work, but for the wrong reason. It passes tests, then quietly fails when reality shifts. And of course, if the AI is trained with the same data set as it is tested on at the end, of course, the AI does not make a mistake. But if you change the data set or if you use the AI in a different environment, then you get this kind of problems. But you would have red flags. You must be aware about red flags. If you have great lab results but weak external tests, hey, this is a red flag. If you see heat maps lighting up the corners, if you want to analyze or examine the lungs of a patient, hey, please, this is a red flag. And sudden drop at new sites is also a red flag that should make you aware about possible problems with your AI. And so, as we did the last time, let's unpack the case, and we do a short 3-minute forensic. We are a little bit in the autopsy. And the first thing you could do in a layperson's language, so the icon with the child in the sandbox, put your hand over the corner where the symbol is. If the robot suddenly can't tell what's on the picture or in the picture, you see that it looks at the wrong place, that it is peeking at the corner. And so this could be a very, very easy check to see if really everything is okay or if there are silent failures. And so what are the 3-minute forensic to-dos? Look at the corners. Are there any logos burned in text, tape rulers, everything like something like this? Do crop tests, blur on the mask the corner and rerun? Do you have differences in your accuracy? Try to do attention maps glow on borders, not on lungs. So make a kind of a heat map sanity. Really analyze your heat map. Where is it shining? Do a site detection. And of course, the most important thing, leave one site out. Hold back entire hospitals during training, then test the AI on the data sets of these hospitals. So remember what I have said at the beginning, really differentiate and separate training data sets from verification data sets. If you have 3 hospitals, train with the first 2 and make the verification with the last 3rd hospital. And also, if you think about shuffle the data sets, also mix the patients and the hospitals, if you train with hospital number 1 and number 2. And here is a little bit highlighted in red what the quality assurance team of this legal manufacturer of this X-ray detecting AI has missed. They split it badly. They had some random splits, shuffle the patients, but not the hospitals. They tested the data set, but not the logic behind it. And they skipped a data audit. This is something that we also detected, that they skipped an internal data audit. And of course, they lacked a plan. And so it is very, very obvious. If you follow the wrong arrow, if you think about traffic signs, you get lost. So first check the arrow, then the walk. And so here we had a bad clue, a logo, a symbol that led to a wrong decision, a wrong triage that resulted in a harm for the patient, delay or an over alarm for the patient. And of course, the trust in the product was gone. And the company really get legal and ethical troubles. And so this is really the risk chain in one line. And you see, if you have planned your setup for training and testing of your AI at the beginning in a wrong way, you will harm your business, your company. And so this is very, very important that you are very precise at the very first beginning of your design and development. And if we think maybe at the end, have some thoughts about controls that work or that may work. These are some simple tools that you really can implement during your design and development and during your verification and validation of your AI functionalities of your software as medical device or AI functionalities in medical equipment. And I divided these controls in 3 groups. Controls that work for data validation. Maybe let's talk in a layperson's language. Then the phrase would be, don't just pass the test in your own room, pass it in a different house. So this is what I never can stop telling you or advising you. Really separate training data sets from verification data sets. So do site-aware splits, implement negative control, do a balance or stratify prevalence across the splits, use data sheets for data sets where you really keep the records, and do some bias probes. And so you will get controls for data and validation, but the most important one is separate the data sets. Controls that work for model and pipeline. Hey, maybe in a lay people language, before baking, write the recipe. During baking, check, did sugar actually go in? And at the end is the sweetness from the cake and not the powdered sugar on the plate. So have installed and implemented a pre-specification plan. Please always try to get explainability as a test. Yeah, the heat map must light up lungs, not logos. The results must be explainable. Not only the results seem the patient is sick, the results seem the patient is sick because the red, yellow shining area is not on the right corner side. And please always think about traceability. Every requirement links to a risk and a test. So the verification of AI, the testing of the AI must be planned in detail during design and development. And there are, of course, some controls that work. If you think about deployment and monitoring, each playground has a scoreboard. If scores drop, call the coach. If you are playing on a new playground, do a practice round. So install per site dashboards if you onboard a new hospital. Implement shift alerts, implement site gates, and of course, implement version controls. This is very important that you freeze your model from time to time so that you are able to trace back failures and problems that occurred during the use of your AI. And so these are 3 simple control measurements or mechanisms that are, I would say, really mandatory for every kind of an AI. And so if you think about the plain language regulatory map, I really want to emphasize, please don't ignore the usual suspects because you are AI. I so often see the excuse or the argumentation, oh, for us, the 13485 does not work because we are software as medical device and artificial intelligence and these and that chapters do not work for us. For example, we do not have storage and transport. Of course you do have storage and transport. You have an app store. The word is in the word store. You have a storage. And upload and download is the transport of your software as medical device. So please don't forget the usual suspects because you think you are something special because you are an AI. Start with the usual suspects. Start with ISO 13485. ISO 13485 gives you a little bit the framework how to monitor and qualify data sets. think about how you monitor and qualify suppliers. And so you are also monitoring and qualifying data sets. You have to train your AI as you have to train your employees. So there are a lot of hints in the 13485 that you can adapt or modify also to your software as a medical device. And of course, don't forget about ISO 14971. Hey, it's your guideline for risk analysis. Don't forget IEC 62304 or 82304, which defines the software lifecycle. And also, what we often also see, don't forget the general safety and performance requirements, which are defined in the medical device regulation, check Annex 1. And the general safety and performance requirements define safety and performance requirements that are general, meaning adaptable and applicable for every medical device. And this list of general safety and performance requirements is nothing that is only to check some boxes at the end of design and development. No, these are requirements. So meaning these requirements must be implemented at the beginning of your design and development process, because it are the requirements that define your design input, your product requirements. And so these usual suspects, please always have in mind and start with them. And then add the specific AI norms and standards. Think about the EU AI Act. If you are a high-risk a medical device, you really have to go and to learn this in detail. And by the way, the Medical Device Regulation and the EU AI Act are both two horizontal regulations, so both apply for you. If you have a medical device, you are under the Medical Device Regulation. If you have implemented AI functionalities, you are, as an add-on, also under the EU AI Act. This is very, very important to know for you. You have to follow both regulations. And at the end, and then we maybe have some time for discussion, but I have to say I have to take care about an emergency in my own company, so maybe I cannot stay until the very, very end. But what I really want to advise you is, don't be afraid of the medical device regulation and friends. What are the friends of the medical device regulation? These are the MDCG guidelines. These are the various standards, ISO norms. And so really read through, because there is also some framework, some guidance given in these documents. Read them, ask them. Yeah, don't Google around, read the originals. And always have in mind that regulatory compliance is your seat belt. This is nothing you do to keep the auditor happy or the competent authority happy. Regulatory compliance is really your seat belt. Why? Because it prevents the crash landing of your product, as we have seen last time with the fertility management, and what we also have seen today with this X-ray imaging analyzing AI. There was really a crash landing for the product, and there was a crash landing for the complete company. The company is gone now. They have not survived this silent scandal. And yeah, as we have thought that if you follow us, this short mini series of regulation of software as medical device and AI, that we give you some small homework. And if you are interested to get a kind of a certificate, so if you are doing the homework, please scan the QR code, and you get at the end a certificate from our site. And this you can use for your CV. This you can show the certification body or the notified body, if the notified body asks, why are you qualified to do AI and software as medical device? So get the chance, you get an official certificate if you do the homework. The last time we also have had a homework there. It was based on describing and defining the intended purpose. Today, we have another homework, and it will take you, I think, 30 minutes to answer our questions. So please scan the QR code if you want to get a certificate for this mini series. If you want to know how we can help you and your company, let's talk, then you get direct a link to Nico Mangold. If you really have a question that we cannot answer in the upcoming 10 minutes, you can stay in contact either with me or with Nico. I just want to show you, I have written in the last semester a small reader, a small booklet called The Evolution of Regulation, a story written in clinical failures. This I offer you to download with this QR code. If you scan this QR code, it initiates an email to my ETH account, and I will send you this small booklet, this small reader. And so please feel free also to follow me on LinkedIn, and thank you for your presence today. And I think we start a little bit the discussion and get Nico on board. Nico, I've seen that you are here, I hope.
Yes, I'm here. I already tried to give some answers in the comments, but I think there are a few questions that might make sense to talk about in the broader field and also live. I think a few questions went into the same direction, and maybe you can give us some more input in that direction. How did no one notice, and how did this problem not come up in the validation of the product?
Yeah. This product came not up at the validation of the product because, as I have said, they have not used different data sets for testing, verification, and validation. The problem came up as they have onboarded an additional hospital, and the problem came up because there was from a junior surgeon always a red flag on results that had the impression that there is no failure. And then the company started a little bit the assessment of the problems and got and asked for the pictures, and realized a kind of a trending where the AI in this new hospital detected always this red and yellow shining area that was 90% not related to the anatomical area of the lungs. But the problem really was a misunderstanding of the medical device regulation and a misunderstanding of quality assurance of software as medical device, especially artificial intelligence, and the strict separation of data sets used for evaluation of the AI system, training, testing, and validation. And one problem, of course, was, in addition, it was a product marketed under the MDR Article 5.5, in-house product. So not a competent authority has overseen the technical documentation. I hope this answers the question.
Very good. So another question, or almost a proposal, I thought was interesting to also talk about, was a step-by-step approach to validating the product. So Laszlo wrote that if it would have been possible to first ask the AI to find the lung in each picture, to start at the bottom and work your way up. I think that's a very good strategy and helps in many use cases. However, of course, even if the AI finds the lung, we still need to go down the road and
yes. This is a very practical hint, and funny thing is, this would be a little bit the calibration of the AI at the beginning before it detects or assesses the picture, so that you calibrate the AI to the spot where it has to look for problems. And I know at least 4 companies that have this kind of a same problem, and all of them have not implemented a kind of a calibration step or a centering of the AI to the field of the problem that should be analyzed. And so this is a very practical thing. It's never nowhere written that you have to do this. But normally, if you think driven or guided by the risk management principles or the usability principles, you should think about this kind of risk mitigation measures, which are very, very logic. Yes.
Yeah, I think a step-by-step approach and validation definitely makes sense.
Yes, and driven by risk analysis and usability should also be something that should not overseen.
Yeah. Then another question by Naureen. Maybe you can help us if we didn't, or if I didn't understand your question correct. They asked if you had a health product marketplace. Is it also important for you to know about like all those things, even if you're mostly only curating others' products? So basically being the reseller or distributor in this case.
If you look at the medical device regulation, that's why I said don't be shy and stick your nose to the original documents. There are the articles 11 to 15 describing the duties and obligations of the various stakeholder or economic players. And yes, of course, if you are a distributor, you are also required to check if the AI is labeled correctly, if it works correctly. You have to hand in the technical documentation if something happens. So you should have a kind of a basic understanding. You don't have to be the expert. Yeah, you don't have to be the software engineer. But the time is over that the distributor is only a distributor and only looks at the cash flow. No, the distributor also has some mandatory tasks, and you can read about this in medical device regulation from article 11 to 14. Article 15 is describing the task of the person responsible for regulatory compliance. And by the way, also the importer, if you are based in a non-EU country, has some regulation or regulatory tasks to fulfill, not only to bring the product over the border. Nico,
very good.
Something to add? You also can answer the questions.
Not from my side, not from my side. So we got another. Sarah wanted those paragraphs again, Dietmar.
These are at the very first beginning of the medical device regulation. Article 10 describes the QMS requirements of a legal manufacturer, and then the articles 11, 12, 13, and 14, and Article 15 describes the requirements of the person responsible for regulatory compliance. So check the beginning of the medical device regulation. It is very, very important for you to know Article 10 to 15.
Perfect. And with 13 being for the importer and 14 primarily for the distributor. And you already talked about, explainability of those AI results. And I think we talked about that also during the lecture. But Adi had an interesting question if we can interpret this as AI creating a confirmation bias that are not really based on facts, and therefore we need partial auditability and explainability of the AI results. And I think that is very correct and very important that you can explain the logic in your AI. Because with that, of course, you still need to do all the validation correctly, but with this in mind, with explainability in mind, you already have a very much better understanding how your own product works and what the risks might be.
Yes, and maybe to add here a little bit more general problem with presenting results in a post-market surveillance, or presenting results in a verification document and presenting results to the competent authority. The explainability so often is missing. Yeah, there is an assessment, there is a test set up, the legal manufacturers run some tests and got some results, and then they only hand in the results. But the result, as a result, is not a topic to reach conformity. You always have to explain the results. You have to find a conclusion. Are these results good or are these results bad? A result is only a number on a piece of paper, and the same thing is here. If this X-ray imaging detecting AI worked, there was no official failure mode. The results displayed always 100% good results, and nobody sat down and spot checked some of the X-rays, because if they would have done a spot checking every 10th, every 20th, something like this, RQL method, maybe you can apply on this at the beginning, yeah. And if someone would have double checked or spot checked or 4I principles, they must have detect the problem, because it's so obvious. If you have this red yellow shining area on the right hand side corner of the picture, that this has nothing to do with the lung of the patient. This is very, very easy to detect, but not for lazy people.
Yeah, I think that is the quintessence of this day's workshop. Just quickly, because some people wrote that the email verification in the form doesn't work, I just changed it, so now it should be open for all kinds of emails. Birgit, I will post the link for the first homework also soon in the chat, but first, Ludovic, Sarah asked if the definition of the GRC responsible in medtech can be extrapolated to other areas. And I would say yes, because safety is important in all kinds of devices. I mean, of course, especially in the medtech field, but in all devices, a safer product is.
Yeah, you always have to remember, if you are, and I agree totally to Nico, if you are playing with the health of a patient, then it is mandatory and you have to show it to competent authorities. If you have a lifestyle product, it should be logic for you that your product should be safe for the patient. And if something happens, hey, they will go against the product and your company. And if you cannot show safety and performance data, then you are lost. So on the one hand side, it's a must, it's mandatory. And on the other hand side, it's a mandatory voluntary job you have to do to secure your product, your business, your cash flow.
Definitely. So I hope I didn't miss anything, but I think those were all the questions asked in the chat. Maybe right now someone has some questions for us live.
So if not, no, maybe Nico, you may explain.
Yeah, I have a question. Okay. Oh, sorry, just a very practical question. I just know that, we did the quote homework, unquote. Are you going to go over some of that in the end tomorrow, just to understand the agenda for tomorrow, or if it's just more that we turn it in and you'll respond to us, how are you going to give us feedback? That's what I'm trying to understand.
Okay. You get in total 3 parts of one homework. Yeah. So for every lecture, you get a small homework, and if you scan the QR code, you will see the questions and the tasks, and after the last day, give us a few days to assess and to review your answers. We will come back via your email address and the certificate. Or Nico?
Yeah, exactly. We will give you some feedback via mail. If you need further, like to talk about that, we can hop on a quick call. But the idea is that after all 3 sessions, we go through all of the answers and then give you feedback one by one.
Yes. And the last session, by the way, is not tomorrow, it's on Thursday. And this will be the 3rd part then also for the homework. And if you have done this, then you get the certificate. Okay.
Now, Birgit just asked who she should contact to take part in the CAS regulatory thinking.
Me.
I think. Perfect. If there are no more questions, I think you have our contact information, so feel free to contact us if you find any more questions.
So we give back.
Yeah, thanks a lot. Great. So there are some questions coming in terms of the recording of the first workshop. So it's all available on YouTube. I shared the link a bit before, and you will find all the on-air sessions and also the Power Workshop first. Thanks a lot to you both. We will have another on-air session today at 2 with Finova, and it's held in German, and it's called Das Skalierungsdilemma, physikalische und konzeptionelle Grenzen des Transformer-Paradigmas. So, du möchtest was sagen? Ja?
I have one question for Nico. Also, if someone missed the first part and goes to YouTube to look at it, the QR code for the first homework still works, yeah, Nico?
Yes.
Okay,
great.
I just changed, like in the email address, it was a very specific filter, so we changed that to be open to all the emails.
The QR work for code for the first homework is still
link stays the same.
And okay.
Great. Then thanks a lot again, and then see you on October 2nd for the next one. Okay. Ciao. Bye.
Thank you very much. Ciao.